Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Amelia Rida Zahra Hardian. You can call me Rida. I'm a student mathematics education at State University of Surabaya. Place of mathematics education A with last 3 digit data number 071. In this video, I will explain a midterm exam question from the Operation Research course, focusing on the graph methods and the simplex methods. Okay, let's discuss the midterm exam question for the Operation Research course taught by Mrs. Afiati and Mrs. Mila in 2025. For number 1, I got the maximum score on the first question. So, this is my answer for the first question. I made mistake in number 2 and 3, namely in the OBE part of the iteration table. Therefore, next, I will continue the discussion of problem solving number 2. So this is the question of number 2. Using the simplex methods, determine the minimum value of g equal to 3x plus 5y plus 4z that satisfies the constraint 2x plus 3y less than or equal to 8, 2y plus 5z more than or equal to 10, 3x plus 2y plus 4z equal to 15, and x, y, z non-negative. First, let's take a look at the objective function. Since this is a minimization problem, our objective function is g equal to 3x plus 5y plus 4z. This means we want to find the combination of x, y, and z that will minimize the total value of g. Next, let's identify the constraint that define the boundaries of our solution. 2x plus 3y less than or equal to 8, 2y plus 5z more than or equal to 10, 3x plus 2y plus 4z equal to 15, and of course, all variables must be non-negative, x, y, z more than or equal to 0. To solve this, using the simplex methods, we need to convert all the constraints into equation in standard form. Since this is a minimalization problem and we have constraint with less than equal to and equal to sign, we will use the big M methods, which introduce artificial variable to handle these types of constraint. Next, let's go through them one by one. For the constraint 2x plus 3y less than or equal to 8, since it's less than and equal to, we add a slack variable or s1. This becomes 2x plus 3y plus s1 equal to 8. For 2y plus 5z more than or equal to 10, we subtract a surplus variable or s2 and add an artificial variable or a1. Now we have 2y plus 5z minus s2 plus a1 equal to 10. For the equality constraint 3x plus 2y plus 4z equal to 15, we directly add an artificial variable or s2, which is give us 3x plus 2y plus 4z plus a2 equal to 15. From this standard form, we put the initial simplex table. This table displays all the essential elements such as the basis, CG value, coefficient, ZG minus GG, and the solution. So, after writing the initial table, we can determine the K column by looking at the minimization case where all ZG minus CG must be less than or equal to 0. If there is a positive, then that is the K column. Then, to find the K row, select the row with the smallest positive ratio. From here, we begin the first iteration, working step by step to move toward an optimal solution by updating the basis variable. Now, when doing this OBE, you need to be careful in calculating. So, after writing the iteration table 1, we can determine the K column by looking at the minimization case where all ZG minus CG must be less than or equal to 0. If there are positive, then that is the K column. Then to find the K row, select the row with the smallest positive ratio. This is a second iteration. This is the second iteration of the simplex table. Now, when doing OBA, you need to be careful in calculating because I have an error in this section. Here is an example of the error. Now, this is the justification. So I was not careful enough to calculate OBA so that the next solution end up wrong too. The solution is optimal at this stage because all value of zg minus gg are less than or equal to 0, which confirm optimality in a minimization problem. However, there is something interesting. One of the non-basis variable has zg minus gg equal to 0. So, this indicates that the problem has multiple optimal solutions. So, we can process with another iteration to explore alternative solutions that are equally optimal. The picture below is the next iteration. Since all of zg minus gg less than equal to 0, the table are optimal. So this minimization case has multiple solutions that are x equal to 7 over 3, y equal to 0, z equal to 7 over 3, or x equal to 0, y equal to 0, z equal to 15 over 4, with the minimum value g mean equal to 15. So this is the question of number 3. Using the simplex methods, determine the minimum value of z equal to 18p plus 12q that satisfies the constraint 3p plus 3q more than or equal to 24, 2p minus 4q equal to 8, 2p minus q less than or equal to 6, also p and q non-negative. Since this is a minimization problem, we begin by identifying the objective function z equal to 18p plus 12q. Next, we examine the constraint 3p plus 3q more than or equal to 24, 2p minus 4q equal to 8, 2p minus q less than or equal to 6, also p and q non-negative. To solve this using the simplex methods, we first convert the system into standard form. Then, we write the constraint as follows. For the first constraint, 3p plus 3q more than or equal to 24, we subtract a surplus variable or negative s1 and add an artificial variable or a1. So, 3p plus 3q minus s1 plus a1 equal to 24. For the second constraint, 2p negative 4q equal to 8, we add an artificial variable a2 because it's an equality. So, 2p minus 4q plus a2 equal to 8. For the third constraint, 2p minus q less than or equal to 6, we add a slack variable or s2. So, 2p minus q plus s2 equal to 6. The objective function becomes z equal to 18p plus 12q minus 0s1 minus 0s2 plus ma1 plus ma2. Now that the system is in standard form, we can process to solve it using the simplex methods. Here is the initial table simplex, constructed from our system in standard form. This table displays all the essential elements such as the basis, CG value, coefficient, ZG, ZG minus GG, and the solution. So, after writing the initial tabel, we can determine the K column by looking at the minimalization case, where all ZG minus CG must be less than or equal to 0. If that is a positive, then that is the K column. Then, to find the K row, select the row with the smallest positive ratio. We then begin the first iteration by identifying the pivot column and row, just like in the usual simplex step. But when doing OBA, you need to be careful and so careful in calculating because I have an error in this section. Here is an example of the error. Now this is the justification. So, I was not careful enough to calculate OBA. So, that's the next solution and up wrong too. So each step brings us closer to finding the optimal solution. Because the first iteration tabel is not optimal, then process to second tabel iteration. Now, we are looking at the second tabel. And good news, this is our final iteration. Why? Because the current table meets the optimally condition. All value of ZG minus CG less than or equal to 0 for a minimization problem. But still there is artificial variable in this space with value more than 0, namely A2 equal to 32. So this minimization case has no solution. So, from this experience, I learned that even obey a part in tabel iteration can be tricky if we don't careful when calculate. That's all for today's explanation on the grep method and the simplex methods. I hope you found it helpful and insightful. Thank you so much for watching and listening. I'm sorry if there is a lot of mistake because I'm still learning too. Wassalamualaikum warahmatullahi wabarakatuh.